Hello friends, welcome to Bindu Dhadwal chemistry lessons. The topic that we take today is some important compounds from nitrogen family. In the topic we'll be covering ammonia and oxoacids of phosphorus. So ammonia is manufactured by Haber's process. In the process, this is the flow chart of manufacture of ammonia. Nitrogen and hydrogen are taken in the ratio 3:1 and passed through a compressor which compresses it to a pressure of about 200 atmospheres. This mixture is then fed into the catalyst chamber at a temperature of 700 Kelvin and a pressure of 200 atmosphere, where the catalyst iron oxide with molybdenum as supporter and aluminium oxide and potassium oxides as promoter will catalyze the reaction and convert it into ammonia. The reaction conversion rate is slow. About 15% of ammonia is formed. Rest about 80 to 85% is in the form of gases. This ammonia at a temperature of 700 Kelvin is then passed through a condensing pipe so that it cools and condenses to a liquid form. The gases nitrogen and hydrogen are pumped through a pumped with the help of a pump and sent back to the catalyst compressor and catalyst chamber so that the process can be repeated again and again. The process is a reversible process which occurs at a temperature of 700 Kelvin and pressure of 200 atmospheres. The reaction is exothermic with enthalpy of reaction minus 92.2 kilojoules per mole. The favorable conditions to get maximum yield, as the reaction is exothermic, Le-Chatelier principle suggests that in order that the reaction should go in the forward direction, we have to keep a temperature low. An optimum temperature about 700 Kelvin is needed. Pressure. As you can see from the reaction, 4 moles, 1 mole of nitrogen and 3 moles of hydrogen combine to form 2 moles of ammonia. So the number of moles is decreasing in the forward direction. So according to Le-Chatelier principle, a higher pressure will favor the forward reaction. So pressure, an optimum pressure of 200 atmosphere is needed. Presence of catalyst. Iron oxide is used as a catalyst with molybdenum, aluminium oxide and potassium oxide as promoters. Ammonia can also be formed by decay of nitrogenous organic matter, for example urea. The reaction is urea plus water forms ammonium carbonate, which is unstable and decomposes to give ammonia, water and carbon dioxide. The characteristic smell coming from the urinals is because of this decomposition reaction. In labs also, we can produce ammonia by reacting ammonium salts with soda or lime. Lime is calcium hydroxide. It decomposes ammonium chloride into ammonia. Similarly, caustic soda, NaOH, can also decompose a salt like ammonium sulfate into ammonia, water and sodium sulfate. Properties of ammonia. It's a colorless gas with pungent smell. It is lighter than air. It's highly soluble in water due to formation of intermolecular hydrogen bonds. So you can see from the diagram that positively charged hydrogen of NH bonds forms a hydrogen bond with partially negatively charged oxygen of water molecule. Ammonia acts as a good complexing agent due to presence of lone pair. Copper will take up pair of electrons from ammonia to form tetraamine copper complex, which is a deep blue colored complex. Ammonia also precipitates the hydroxides of many metals from their salt solution. For example, when ferric chloride reacts with ammonium hydroxide, brown colored precipitates of hydrated ferric oxide are formed. So this is the basis of the detection of iron radical in group 3 when practicals are conducted. Zinc sulfate when reacted with ammonium, or zinc salt when reacted with ammonia liquor, will form white precipitates of zinc hydroxide. So presence of white precipitates on adding ammonium hydroxide indicates presence of zinc in a salt. Uses. So it is used in the preparation of fertilizers like calcium ammonium nitrate, urea and diammonium phosphate. Liquid ammonia is used as a refrigerant, and it is also used to prepare inorganic compounds like nitric acid. Oxoacids of phosphorus. Hypophosphorus acid, formula H3PO2. The oxidation state is +1, and in this there is one phosphorus OH bond and two phosphorus hydrogen bonds and one phosphorus oxygen double bond. Hypophosphorus acid is formed from orthophosphorus acid by removal of oxygen. The word hypo is added if one oxygen is removed. So you can see in orthophosphorus acid there are two phosphorus OH bonds, and when one oxygen is removed it forms the hypophosphorus acid. The oxidation state of phosphorus in orthophosphorus acid is +3. Pyrophosphorus acid is formed when two orthophosphorus acids are heated for elimination of water molecule, and they combine with each other. H4P2O5 is the formula, +3 is the oxidation state, and structure is similar to phosphorus acid except that one of the OH of each orthophosphorus acid will combine to eliminate water and join by oxygen. Hypophosphoric acid, H4P2O6, oxidation state +4, the two atoms are directly joined. Orthophosphoric acid has 3 ionizable OH bonds and one double bond O, P double bond O bond. So it's a tribasic acid. Pyrophosphoric acid, H4P2O7, is formed by heating two phosphoric acid molecules. With the elimination of water molecule, the dimer is formed. Oxidation state is +5. Metaphosphoric acid exists as a polymer. It may exist in a cyclic form or in a linear polymer form. It contains, each individual unit contains one ionizable hydroxide bond, so it's monobasic in nature.